Okay, hello, my name is Frank and I'm from Mindset team and I would like to show you our research on drones CV. We take datasets from that source, drone dataset ICG to grass.aid, and we did small research for segmentation problem for drone sim images. So let's review our notebook and see results, what we can get from segmentation for images from drones. So firstly we import our libraries from what we have. One of the major libraries is PIL. Library to working with image, it's OpenCV library, and of course Torch Vision library with retrained networks, faster CNN and master CNN. We also use own packages for augmentation, for metrics calculations. We use also Cocoa engine to simplify our research, but in general it's completely PyTorch and Python code. So let's have a look what we have. We have original image and label images for semantic segmentation. We see that it is images from drones, and they have a very good segmentation markup, very good annotation for different objects on that image. So we see trees, private area, grass, and so on. Person, people, and so on. We have two sources of annotation. One is from Kaggle, and second one is original one from original site. They're a little bit different, and we decided to use original one to understand that we take data from source. So this is that is how images from original source looks like, and annotation from it. Then we defined our dictionary with different colors, and with each color is connected to our class. For example, color as 128, 64, 128 is connected to paved area, and so on. Then we built a class dataset, which is Torch, get from Torch utils data dataset, check dataset just to check that colors of images are connected to each class, just to verify that it's true. And then we moved further, just checking that dataset and understand that each class is, we can connect each color on the from the source, so we can connect to class. Then we just checking files, and then we just check that, for example, class 3, number 3 is grass, and we check that masks with third class is really grass. So we see here that on the up right corner we have a lot of grass, so it's true. Yeah, and grass also here for second image, it's true also. So it seems it works okay. Then we can move further. We just create a dictionary with after a connection of each number of each class, we connect to the name of each class, number to name. So then we create drones segmentation data set. It's in a way which PyTorch should take. So it's in a initialization, get item point, and then in that get item, one of the most important things that we have about 24 classes, and we create masks, bounding boxes for them, and just create target and image, which we're using in our research. Image is our data and target is our target. So then we just create simple transformations. Here we didn't any augmentation because data is quite big, but I think we can improve our quality to do annotation. Then we use num classes 25, and then we build a function at instance segmentation model where we initialize our model, and it is master CNN ResNet 50 VPN for backbone, and final layer is masker CNN predictor. So it is a pre-trained network because quality of that network seems much better than not pre-trained. If we fine-tune our models, then we create our dataset batch size 2 because image is quite big. It's about 4,000 to 6,000 pixels, and then we create our data loaders for our train dataset and test dataset. After that, we move forward and create our device. It's CUDA 0. We have about 6 video cards, but GPUs, but we use only one here. Then we initialize our model with number of classes and move our model to device. Also, we should get our parameters. If P requires gradient and optimizer, it's AdamW, but SGD is also okay for the task. Then we built a learning rate scheduler to change our learning rate during training process. Okay, then we start to build our model, to train our model using simple cycle, train one, epoch one by one, and calculate and save our model to that path. And we see that loss is decreasing on each step, and it is on the last steps, and at the beginning it was higher. Here we have about 9 models, about 10 we have 10 models here, and let's have a look how they are they good or not. We built several functions to understand to work with images, and then we just in cycle check how to see how our model works. This is initial image for training set, and then we got tensors with labels and tensors with scores, and we see that for class 1 we got score 0.45, and it is relatively high, and this first score is asphalt or paved area. Asphalt it is in Russian, and we see that model find this paved area, and then we see also this find person as человек, and so on with different scores. We see that model looks like work okay. Then we can move further and check that model on test dataset, and we see we have image here, cars, paved area, roof, and so on. So first class with probability 0.76 is class 9, and it is a roof in Russian Krysha, and we see that model found that. And so on. Vehicle is also what we can find here, and also different classes. Then we can check our measure our metrics. Let's define functions to take to measure metrics. It's intersection over union, f-score, precision, recall, accuracy, and so on. Here we want to calculate three metrics: intersection over union, recall, and precision. Build metrics calculation function where in cycle we put inside a score limit and class num. For example, if we want to calculate score for person, we put class 15 and score limit more, for example, than 0.3, and then calculate our metrics for each image and for whole dataset. Let's look at results. It's just additional functions that allow us to calculate better. So we're beginning, and after calculation for 10 images, and for 17 class it's vehicle class and 0.1 score, we see that we got intersection over union is 0.55, and precision is 0.56, and recall is quite high, 0.99. At the end, for whole dataset, trained dataset, we see that our results is here, and it's 0.6 for intersection over union and precision, and for recall it's 0.98 approximately. Then we can calculate this metrics for the dataset test to check our results. In dataset test we have 50 images, and we see that for test datasets metrics even higher than for trained dataset. Okay, also we can calculate, we can increase our score limit and check results. For trained dataset we got quite high score, so we have less wrong pixels in our masks, prediction masks, and we got quite good result. For test dataset we also got a quite good result, and they are relatively close to what we have for trained dataset. Okay, for class 15 for person, and score limit is 0.3 or higher, we got not very good results. So we have 0.11 for precision, for intersection of union, so it's quite difficult to find person exactly, but we have relatively high precision and normal recall. And for test dataset we got closer results. So for future we can do synthetic data mechanics when we put data on our images, or we can use augmentation, additional augmentation, which allow us to get additional results for that task. So I hope this tutorial will be useful to understand what we can to do for you, and you can find another videos on our channel. So I hope it was very useful. If you have any questions, please write your questions below this video, and see you soon. Thank you very much.